video, we are going to explain some of the important examples based on permutations and combinations. So the first example is a person wants to buy one fountain pen, one ball pen, and one pencil from a stationery shop. If there are 10 fountain pen varieties, 12 ball pen varieties, and 5 pencil varieties, in how many ways can he select these articles? So the number of the fountain pen varieties is equal to 10, number of ball pen varieties is equal to 12, and number of pencil varieties is equal to 5. So the number of the ways to select one fountain pen, one ball pen, and one pencil is equal to 10C1 into 12C1 into 5C1. 10C1 is equal to 10, so 10 into 12C1 is 12, into 5C1 is 5, so 10 into 12 into 5, that is equal to 600. Now example number 2, how many 4-digit numbers can be formed with the digits 3, 5, 7, 8, 9, each of which is greater than 7,000 if repetition of digits is not allowed? So the available digits are 3, 5, 7, 8, 9. Now since every number must be greater than 7,000, so 1000 place has 3 choices, that is 7, 8, 9. And for the remaining 3 places, we have 4 available digits because one digit is fixed at 1000 place. So leaving that digit, we have 4 remaining digits to fill the remaining 3 places. So 100 place has 4 choices. And now tens place has 3 choices. And ones place has 2 choices. So number of 4-digit numbers greater than 7,000 is equal to 3 into 4 into 3 into 2. That is 3 3s are 9 and 4 2s are 8 and 9 8s are 72. Example number 3, how many 9-digit numbers of the different digits can be formed? So we have 10 digits 0 to 9, but the 9th digit from right to left could have any digit except 0, because if we write 0 here, the resulting number must be 8-digit number, not 9-digit number, because 0 at the leftmost place is an insignificant figure. So we have only 9 choices. So now the 9th place from the right has 9 choices, and for the remaining 8 places, all the digits including 0 are available except one digit which is fixed at the 9th place. So remaining 8 places can be filled with 9 digits. So 8 places out of 9 digits, that is in 9p 8 ways. So total number of nine-digit numbers of different digits is equal to 9 into 9p8. That is equal to 9 into 9p8 is 9 upon factorial 9 minus 8. That is equal to 9 into factorial 9. So example number 4, let m men and n women are to be seated in a row so that no two women sit together. Then find the number of the ways in which they can be seated if m is greater than n. So this can be done in a way that between every two men there must be a vacant seat for a woman. So no two women are sit together. So we have to make m1 blank seat m2 blank seat m3 and so on to mm. So for example, there are 3 men being seated in that way. There are 4 available seats for women, and if there are 4 men, there are 5 available seats for the women, so that no two women sit together. So if there are m, so number of men is equal to m. So number of available seats for n women is equal to m plus 1. So now we have to fill m plus 1 seats with n women. So number of ways in which m men can be seated is equal to factorial m, and number of ways in which n women can be seated is equal to m plus 1 p n. So the total number of ways in which m men and n women can be seated so that no two women sit together. Is equal to factorial m into m plus 1 pn. That is equal to factorial m into factorial m plus 1 upon factorial m plus 1 minus n. which is equal to factorial m into factorial m plus 1 upon factorial m minus n plus 1. Now example number 5, in how many ways can a lawn tennis mixed double be made up from 7 married couples if no husband and wife play in the same set? So number of men is equal to 7 and number of women is also equal to 7. We may select any 2 men out of 7 men, but for the mixed double, we may select any 2 women out of 5 women, excluding 2 women must be excluded, as these 2 women are wives of the selected 2 selected men. Thus, number of ways to arrange 2 men out of 7 is 7p2, as in the case of matches, the sequence of men is taken into account. And number of ways to arrange 2 women out of 5 is equal to 5p2. Thus, the number of ways in which the tennis mixed double matches can be made is equal to 7p2 into 5p2, which is equal to 7 factorial upon 7 minus 2 factorial multiplied by 5 factorial upon 5 minus 2 factorial, which is equal to 7 factorial upon 5 factorial multiplied by 5 factorial upon 3 factorial, which may be simplified as 6 into 7, because factorial 5 will cancel factorial 5 out of factorial 7, and 4 into 5 because factorial 3 will cancel factorial 3 out of factorial 5. So we have 6 7s are 42 into 4 5s are 20, which is equal to 840.